To create geometrical relationships between parts in an assembly, we can use something called derived geometry. Derived geometry allows us to define part geometry in an assembly context, serving as a form of design intent, where a change in one part results in a corresponding change in another. Let me switch over to a different assembly. Here, we simply have our main part inserted. This will be the part with our driving features, from which other parts will have to match. Creating a derived part is a top-down approach, where a part is modeled within an assembly. I'll first begin by inserting a component, which will be a new part. To edit this part, I'll make sure to be in Edit Part mode and create a sketch on the bottom face. We're going to be creating the bottom cover for the part. I'll be selecting the existing part's profile and use the Offset tool to create the sketch for my new cover part. Now once the sketch is added, I want to turn our attention to the Feature Manager tree. Next to the sketch we just created, notice there's an arrow, meaning that this sketch is derived. But what exactly does this mean? Well, let me show you. Since the sketch was defined with respect to existing geometry, any change made in the referenced profile will be reflected in our sketch. This same concept applies to features. For example, I can make this an extrusion and offset it to always be a certain distance from this surface. I'll make some final adjustments and click the green check. Now let's see how this feature behaves. If I go ahead and change the main part's depth, we see the extrusion keeps its specified distance, maintaining our design intent. There's a variety of features that can be used to take advantage of this parametric power. Another useful example might be the cavity feature. I can launch this feature from under the Insert Features drop-down menu. The cavity feature allows you to select a separate part in order to create a cut. Again, since this cut was defined by the main part component, any change to it updates the cavity feature. Now, as you can see, using derived geometry as a form of design intent can be a very powerful tool, especially when working with parts that must fit together.